guys, so today I want to talk about the technique of integration. So in BiPAT we have the formula that we must know, which is okay, for this is the question that given to us, and this is the formula that we must know. So the formula is about u, v and du. So if you want to use this technique, you must know how to find u, how to find v, and how to find du. So first of all, you must know how to find the u. Okay, so guys, to find u, you must know the LPAT. So this is the sequence. So the first one is logarithm, the second one is polynomial, the third one is exponential, and the last one is trigonometry. So in the question, you must follow the rule, and the first one must logarithm. So if the question have two of this, which is logarithm and polynomial, you must choose the logarithm first, because this is the number one at the LPAT. So I will give the example, the two example, and the first one is this: integrate x e power of x dx. So first you must find the u, and so I choose x as my u, and after that you must integrate the the x, and you get du equal to dx. And after that you must search the v value, which is you follow the formula, integrate dv equal to integrate ex dx. So you must take all of this, and you get v equal to ex. So after that you write the question again, and you equal to the formula u, this is u, this is v, minus integrate v du. If you look at the solution at this side, at this side, you just write the same solution. So you just stay the solution like this, and the part that we must calculate is this. So integrate ex dx. So if you integrate ex, you get ex plus c. So c, you must write the c, because c is consistent value. So we must put the simplest solution, which is this. So the second example is integrate x square e power of x dx. So this is the second example, and I choose the x square for the u. So you differentiate the x square, you get du equal to 2x dx. And for v, integrate dv equal to integrate ex dx. So you get v is ex. And after that, you just write the question, and just I said before, this part you just stay it. So you don't to change or whatever. So the first one, this. So you must integrate ex to x dx. So for this, you can take out the 2 in front and get this, and so you just have to integrate x ex dx. So for integrate this question, this is the solution. So you just select u and find dv, and you get this, and you put at this, and you get this 2 x e power of x minus integrate ex dx. So at this part, you also must use the BiPAT technique. So after you do a BiPAT technique, you get this, and this you must integrate again, and you get ex plus c, and you just, and after that you just times 2 times x e power of x, 2 times ex, and for the c you don't need to times, because it's a consistent value. So you get the final answer is okay. That's all from me. Thank you.
Okay, hello guys. Today I will teach you about integration by substitution, or we can call them IBS. What is IBS? IBS is used to simplify the integral by substituting the independent variable by others. And when we need to use the IBS, we need to use IBS when the integral is in the special form, which is f gx times g prime x dx. So when the integral is in this form, we just can substituting them by u equal to gx and du equal to g prime x dx. For example, we have the question that integral x square square root x power of 3 plus 1 dx. So square root is the f and x power of 3 plus 1 is their gx. So we know that u is gx, then we substitute u equal to x power of 3 plus 1. So what is the du? We can find the du by differentiating u. So du over dx, we get 3x square, and then we can find du by put dx to the other side, and we get du 3x square dx. In the question, we have x square dx. So to make it more simple, we just can simplify the du, and we put this 3 into the other side, and we get 1 over 3 du equal to x square dx. So we just need to substituting them into the question, and we get integral 1 over 3 u square root du. Sorry, we get integration 1 over 3 square root u du, which is u is x power of 3 plus 1 and 1 over 3 du is x square dx. Okay, next step, we just need to integration them, and we know that square root u is u power of half, and then we just integration them like usual, and we get 2 over 9 u power of 3 over 2 plus c. This is the final answer? No, we need to substitute back the u to the original form, which is x power of 3 plus 1. So we get the final answer is 2 over 9 times x power of 3 plus 1 power of 3 over 2 plus c. Next, the other question, we have trigonometry. We have integral tangent x dx. We all know that tangent x is sin x over cos x dx, right? So what we need to do is we take cos x as gx, and we substitute cos x as u, and find the du by differentiating u, and we get negative sin x. So the du is negative sin x dx. We have positive sin x here, and we just bring this negative to the other side, and we get negative du equal to sin x dx. So we just need to substitute them by negative du over u, and we put the negative to the outside, and we get du over u. To make it simple, we can write du over u as 1 over u du, and we just need to integration them, and we all know that integration of 1 over u is ln u. Then we get negative ln u plus c. Is it the final answer? Yes, not yet. We need to substitute this u back to his original, and we get negative ln cos x plus c. Simple. That's all from me. Thank you.
Good morning to everyone. Today I'm gonna present about what is special fraction. So special fraction is algebraic form that we use to down to a simpler fraction or the simpler one. So in the integration case of integration 1 is I'm gonna make the partial fraction in integrate form. Actually, we're gonna know that we must know that the rational express form, where and how we're gonna simpler the algebraic form in partial fraction. I'm gonna use the rational express form, which is fx equal to px over qx, where both px and qx are polynomial, and the degree of px must be smaller than qx. If the px are greater than qx, then we can do the simpler down, or what we call as decomposition. So I take this equation for example, 3x plus 11 over x2 minus x minus 6 dx. So firstly, we're gonna factorize the denominator, which is this one, and then we got x minus 3 and x plus 2 dx. What we do for the next step is we're gonna find which type for the decomposition for this form. So we have 4 types of the factor of denominator that we use, but in this case we use a over x minus 3 plus b over x minus 2. Then we move to the next step. What we do here is actually we equalize the denominator, which means multiplication here, so we get the same denominator. Then we get this. So after we equalize the denominator, then we set the numerator equal. So what we saw here is this is above x, so we can use to plug into the equation lah. So x equal to minus 2, then we plug in x equal to 3, then we plug in, so we got b equal to -1 and a equal to 4. So we substitute again to here, then we got this form, then we integrate it, so we got 4 ln modulus x minus 3 minus ln modulus x plus 2 plus c. So that's all for me. Thank you.
Okay. Assalamualaikum and very good morning. So today we are going to learn about trigonometry integrals. It is one of the techniques of integrals. So when we heard about trigonometry, we will know that it's about like sine, sinus, cosinus and tangent, right? So back to basic. So the trigonometric integrals is same as it. So the most important about trigonometric integrals is about trigonometric identities. So this is basic trigonometric identities, which is we call it Pythagorean identities.
So there is more types of identities that we learn, but today I want to focus about Pythagorean identities. So for the example one, so this is a question. Integrate cos cube x dx. So as we know, we integrate it like usual. So but we have cos cube, cos power of 3. So how to integrate it? So for the first, we can expand the cos cube to cos 2x times cos x. Because cos 2x times cos x, we got cos cube, right? So they are cos square x. When we look at the trigonometric identities, so they are cos 2x here. But sin 2x plus cos 2x is 1. So we can adjust the cos 2x. So we adjust and we replace the equation from this to cos 2x that we want. So we got 1 minus sin 2x. So after we substitute the identities, so we can do the u substitution. So u is sin x. So when we integrate sin x, we got cos x. So we integrate the u is sin square x. So we integrate the sin 2x, it gives us cos 2x. So at this equation, we can replace it with u. So why we replace it u? Because we want to easily integrate. Because when we integrate like sin 2x and cos 2x, it is difficult to integrate it. So when we substitute it with u, so we can integrate it like usual. So integrate all of this, and we got u minus u cube over 3 plus c. So but this is not the final answer. We must substitute it again with what we integrate before. We substitute it, and we got sin x minus 1 over 3 sin cube x plus c. So this is the final answer for example 1. So let's move to the example 2. So we got here integrate cos 5x times sin 4x dx. So it is difficult to integrate, so we can expand this equation to cos x times cos 4x sin 4x. Why I expand it to cos x times cos 4x? Because we can, from the 4, we can expand it to 2 times 2, right? So we do the usual solution. So at here we have cos 2x, which is this is from trigonometric identities. So we can use the trigonometric identities to substitute it with 1 minus sin 2x in the bracket power of 2. So we integrate the u equals to sin x, we got cos 2x. So we sub sin 2x with u, and we got 1 minus u square in bracket square times u for du. Du is from sin x, so we got u for cos x is du. So we put it in the back to easily we integrate. So this is 1 minus u square power of square. So we simplify it like usual. So we got 1 minus u square plus u4, and we plus minus, and we got the final answer is 1 minus 2 u square plus u4 du. So we times the u4 in the bracket, and we got u4 minus 2u6 plus u8. And after we simplify it all, so we integrate it, and we got u5 over 5 minus 2u7 over 7 plus u9 over 9 plus c. So after we integrate it, we substitute the u with this equation. So the last final answer, we got 1 over 5 sin 5x minus 2 over 7 sin 5x plus 1 over 9 sin 9x plus c. So this is the final answer. So what I can tell it, the most important is you must know about the trigonometric identities. This is one of the type of the trigonometric identities. There are more. So you need to study about identities, so you can do all the questions about trigonometric integrals. So that's all for me. Thank you.